Okay, so after you learn about all of the features of a specific type of function, then what do you do with it? You learn about how to model with it, right? So that's what we're going to look at with quadratic functions today, how to model real-life situations with quadratic functions. They are incredibly applicable when it comes to modeling things. Let's look at some examples. So first, we have this curve here. It's a quadratic. So the graph shows a quadratic function of the form p of t equals a times t squared plus b times t plus c, which approximates the yearly profits for a company where p of t is the profit in year t. So this is a quadratic function. Instead of x, we're using t, because t is standing for years, so it's time. And the y values represent profit at a given time in years. So first question, is the value of a in this equation positive, negative, or 0? Well, from just the equation, we don't know, but from the graph, we do know. So pause the video, write down, is it positive, negative, or 0, and your reasoning why. Unpause when you're ready to discuss. All right, so hopefully we said that it's positive. Now, you might have some different explanations than I do, but the two that I came up with were, I can see that the graph opens up, right? That it has this general sort of shape. It's much shallower than that, but still it opens up, so it's a positive parabola. Another way to say it is the graph has a minimum value, right? So I kind of tried to identify where I think the minimum is. It's somewhere around here. It's hard to see exactly, but the graph has a minimum value. Okay. Next part, write an expression in terms of A and B that represents the year T when the company made the least profit, right? So what is this saying? Well, this is a really fancy way of saying what is the H value of the vertex. So if this is my vertex, HK, then H represents T when this occurs. So how do I find H? What's our relationship between H, A, and B? Well, we know that H is opposite of B over 2A. So that is an expression. Well, the expression part is the negative B over 2A that represents the year T when the company made the least profits. So that is an expression. When I have the equal sign, it's an equation. Without the equal sign, it's an expression. All right, and then part C, same problem. The company made the same yearly profits in 2004 and 2012. So estimate the year in which the company made the least profit. Well, again, if we know it's a parabola, we know that there is symmetry, right? And so if I think about this, if I just draw a generic parabola, and I'm going to call this point 4, y, and I'm going to call this point 12, y, then I know the minimum, right? So when did it make the least? Had to occur at the vertex, which I know is the average of those two x coordinates. So 4 plus 12 over 2, 4 plus 12 is 16, 16 over 2 is 8. So that becomes 8. I can apply that same thing with 2004 and 2012. So 2004 plus 2012 over 2 is going to equal 2008. So 2008 is when I am going to believe that the company made the least profit. Next question. Assuming that the model is still valid today, are the yearly profits currently increasing, decreasing, or constant? Well, if the model is still valid today and the minimum occurred in 2008, then theoretically it should still be increasing because we are past 2008 and it has been going up since then. Okay, so next one. Here, the graph shows the parabolic path of a performer who was shot out of a cannon where y is the height in feet, x is the horizontal distance traveled, and we want to write an equation of this performer's path. So as we do that, though, I want to point out that projectile motion, which is what this would be considered because it's something being fired out of a cannon in this case, is one of the major applications of quadratic functions. So how do we go about this, though? Let's think about our generic quadratic function, y equals a times x minus h squared plus k. Great. Well, right here, that's the vertex, so that's my hk. So already I know y equals a times x minus 50 squared plus 35. Now, how do I find that a value, though? Well, to do that, I'm going to use other information that I have. And in this case, I'm going to use the y-intercept. This is a really easy point to use. And we've seen this even when we deal with, like, the equation of a line, right? If you're missing a value, but you know a point, plug that point in. So I know that y is 15 when x is 0. So now I'm going to go to my trusty calculator and I'm going to solve for a. So if we subtract the 35, we get negative 20 equals a. And if I do negative 50 squared, remember if we square a negative, we should get a positive number. That's 2,500. And so if I do negative 20 divided by 2,500, and then I'm going to simplify that by changing it into a fraction on my calculator. So this is negative 1 over 1/25 equals a. So therefore the equation that I want is y equals negative 1 over 1/25 times x minus 50 squared plus 35. That's the equation. Next problem, or still part of the same problem, it says the performer lands in a net 90 feet from the cannon. What is the height of the net? I want you to try to do that part on your own now that we have the equation. So pause the video, see how you can use the equation to find that information. My hint is think about what the variables actually represent. Remember, this is why it's an application problem, is that there is context to what x actually means and context to what y actually means. So pause the video, try to find the answer to the second part. Unpause when you're ready to check. Alright, so hopefully for you get this, you got 22.2 feet. And so how did I do that? Well, I plugged in 90 for x. How did I know to plug in 90 for x? And that's what I was trying to hint at before I paused the video. And that is that the horizontal distance is represented by x, and 90 is a horizontal distance. Right? The vertical distance is represented by y, so that's what I'm trying to find. So I plugged in 90, I typed this into my calculator very carefully, and I got y equals 22.2. And I know that that's in feet, because that's what my units tell me. Now, if I look at the graph, that also makes sense, because this is between 20 and 25, so that's 22.2. Okay, so next one, I want you to try this one on your own, but if you follow what we did on the last problem to come up with the equation, it's the exact same thing. There's just no context to this, so this isn't an application problem. This is just practicing that process. So pause the video, try to find the equation of the parabola. You know a point, and you know the vertex. Pause the video, unpause when you're ready to discuss. Alright, so hopefully you got y equals 11 over 25 times the quantity x minus 4 squared minus 9. How did I come up with that? Great question. So first I started with the equation of a quadratic in vertex form. So we have y equals a times x minus h squared plus k, right? But we know the vertex, 4, negative 9. So I'm going to plug in the 4 for h. I'm going to plug in the negative 9 for k. Now we need to find a. How do we find a? That's where we use the point. So I take the point, negative 1, 2, and plug that in for the x and the y. Now I just do arithmetic, add the 9, square negative 5, divide by 25. Just leave it as 11 over 25. That's fine. We don't need to type that in the calculator. And now just rewrite my equation that I had up here in the black, except for plug in the value for a. Okay, so now this one I'm going to ask you to stretch a little bit further because we haven't done one exactly like this, at least today, but you've done problems like this before. So I want you to write an equation of a parabola. You know it goes through the 0.25 and it has x-intercepts -2 and +4. If you want a hint, is to do a quick little sketch. I know that I have x-intercepts here and here, and I also go through the point 2, 5, so there's a point up there. Maybe that helps you, maybe it doesn't. So I want you to try, pause the video, see if you can come up with the equation, unpause when you're ready to check. Okay, so the picture helps us understand that the parabola should open down. The easiest way to do this problem is to use factored form, right? The question doesn't tell us we have to have our answer in a certain form. Now, if we needed to, we can easily do a little bit more work and go from factored form into vertex form or ABC form, but it doesn't tell us. So we can just leave it in factored form since we have the x-intercepts. So factored form is y equals a times x minus p times x minus q. Since I know my x-intercepts are -2, 4, I know this is x plus 2 and x minus 4. I need to find a, so just like before, I plug in the point. So I plug in 5 for y and I plug in 2 for x. Simplify this, 2 plus 2 is 4, 2 minus 4 is -2, -2 times 4 is -8, divide by the -8, a is -5/8, rewrite my equation. Okay, last one. This is again a little bit of a stretch maybe. It's a little more difficult than some of the other ones we've done in this video. But, you know, again, as always, I believe in you. I think you can do this. So we're going to do one step at a time, but I still want you to try to find these on your own. So the first, we have this object, right? It's launched straight up at 48 feet per second. The height in feet of the object is given by this equation, where t is time in seconds since the object was launched. So the y values or outputs are height, the x values, or in this case t values, are time in seconds. At what height was the object launched? So I want you to try to answer this. I'm going to have you pause the video, but my hint is think about what time was the object launched. Like if you start a race, how much time is on the clock when you start the race? That should help you figure out what height the object is at. Pause the video, unpause when you're ready to discuss. Just part A. Alright, so hopefully you got 8 feet. How do we come up with that? So again, if you think back to my race analogy, right before you start the race, there's 0 seconds on the clock, right? So right before I launch something and time it, there's 0 seconds that have gone by since I launched it. So I plug in 0 for t. Another way to say this is going to be the y-intercept. And since this is ABC form, I know that that's just 8. Part B. When does the object reach its maximum height? So think about, well, what do we mean by maximum height? What else do we call that? We call that the vertex. So when we say when does it reach the maximum height, we're talking about the h value of the vertex, because that is normally what we would say is the x-coordinate, but in this case it's t. So I want you to find that. Pause the video, unpause when you're ready to check. Alright, so hopefully you got 1.5 seconds. How do I do that? Remember, h is opposite of b over 2a, so in this case that's -48 over 2 times -16. Type that into my calculator, that's 1.5 seconds. Part C should be pretty straightforward if we got part B. What is the maximum height of the object? So if we know the h value, how do we find the k value? Pause the video, unpause when you're ready to check. Okay, hopefully you got 44 feet. How do we get that? We just plug in the 1.5 into our equation everywhere that there's a t. Type that into our calculator, we get 44. Last part, how long is the object at or above 28 feet? This one's going to be a little bit more work. We're going to use our calculator for this, so go ahead and get out your calculator. Okay, so here I have my calculator. I'm going to type the equation in. We're going to use x instead of t, just because that's what the calculator has. Now the other thing we're going to do is for the y2, we're actually going to type in 28, and I'll explain why in a second. So if we do our standard window, if I hit zoom standard and I hit graph, this is what I see. That doesn't totally help me, so I need to adjust my window. Let's think about, we know that the x is time, so I don't care about negative time. I know that it hit its maximum at 1.5 seconds, so let's go to 5. And then the y minimum is height, so that we don't care about. And y max, we know that it went to 44, so let's go to 50.